Hello and welcome to Microsoft Mechanics Live. Coming up, we're joined by Julia White for a look at Microsoft's approach to AI. And we're going to also make it real by taking a look at some of the practical applications before breaking down how you can leverage AI for your own apps and services and online experiences across the areas of knowledge mining, cognitive services, and machine learning. But please join me in welcoming Julia White, CVP of the Cloud Enterprise Group.
Thank you so much. It is awesome to be back on Mechanics after a year or so hiatus.
Thank you. So we're seeing lots of innovation. We're seeing lots of buzz around AI.
Yep.
It's being used a lot, that term. I think in the past we've covered deep learning with a lot of custom ML models, stuff that data scientists do, and a lot of us are probably data scientists, but on this show, we wanted to actually give everyone a real-world set of practical ways that they can actually integrate AI into their own apps.
Right, this is really important because we don't want AI to just be in the hands of a select few. Our focus is really on making AI, machine learning easier and more accessible for everyone to use, and that's really the key focus. And for the past decade, we've been integrating AI into a lot of our cloud services. One of the early implementations, actually, you remember, was an exchange online of distinguishing what was good mail versus junk mail. It's just a really early example. But of course, AI is an integral part of Bing Maps and Bing Search, and of course, the facial and biometric authentication with Windows Hello, also using AI, and then infused into our Office 365 experience, right, with PowerPoint Designer, Word Grammar Checker even. And then we also use AI pretty pervasively around security, right, and using all of our advanced threat protections, or underlying that our cloud services is using AI and our security technology. And now we've taken a lot of that technology that we've used internally for all of those applications and turned it into Azure AI services that you can use in your own applications. And this includes many of the pretty sophisticated pre-trained ML models that we've now turned into Azure Cognitive Services. And we've also enabled support for the most popular AI frameworks, so you can train your models using a number of different frameworks and a very open approach on that front. And of course, for those people who need something very highly specialized, you can also collaborate and build your own custom machine learning model using Azure as well. So regardless of whether you're using a pre-trained model or a custom ML model, you can always, of course, get the AI compute you need with Azure, and then go ahead and deploy and run that either in the cloud and or on the edge in that area.
Right, so we're really doing a lot in terms of democratizing AI and really making it available for everybody to use. So why don't we get to this and actually make it real and show people a couple of demonstrations of what we can do?
I love it. All right, so great. Let's get started with an example of knowledge mining. Now, this is about quickly getting insights in all of your existing information within your organization. So for example, I'm assuming many of you have been around for a long time, your businesses have been, and you have a lot of data you're sitting on, but it's probably sitting in things like file cabinets or scanned in some archive. It could be written, it could be pictures, it could be videos. So what if you could use AI to add structure to that data and then have it indexed and easily searched? Or even more powerfully, you can discover different patterns or relationships within that data by surfacing those insights. So let me give you an example. So let me switch here to, we have a JFK example. So about 25 years ago, the Act of Congress mandated that the documents related to the JFK assassination became declassified. So last October, they released 34,000 pages of documentations.
So 34,000 pages is a lot. That's probably, how high would that stack up?
I'm going to say least to the top of that wall right behind me in terms of images. So first of all, we took that enormous stack of data, or paper, and we digitized it, and then we put it in Azure. And then we applied Azure Search with cognitive services, where we're able to intelligently annotate and index that information to make sense of it, find relationships, and surface new insights. Then we built a simple web app on top of it so you can literally interact with this data, and it's a site you can all go to as well. But let me show you how it works. So I'm sitting out at the web experience, again, on top of that data repository that's been searched and indexed. I'm going to go ahead and search on Lee Harvey Oswald. Hopefully everyone knows his relationship to the JFK assassination. So go ahead and search on that. Now you can see over here on the left, Azure is kind of pulling out different key entities based on the contents of the document. So you see things like the CIA and JFK, of course, and Lee Harvey Oswald all make sense. Over here on the right, you can see a variety of different documents. And you can in fact see that his name is actually highlighted. And it could be like typed information here, written in this example, scanned and other things. And even if using optical character recognition or OCR, that cognitive skill, we can annotate that text document to make it searchable, even though it was handwritten. And now if I scroll down, you can see it's capturing a picture too. So Again, because we're using computer vision, the cognitive skill, I can understand the content of a picture as well. So if I click on this, you can see it recognizes that's Lee Harvey Oswald. You see the name is actually highlighted here. And you can go down. It's actually scanning over this. You can see it's giving me an annotation, again, using that OCR capability within the image itself. So go ahead and close that out. Now, the next thing I can show you is also about the relationships that's found between the information. So if I click here on the graph site, it's actually pulling together a graphical representation of the relationships across specific terms that it found across this whole body of documentation. So if I grab Oswald here, for example, you see kind of a cluster of information circling around him like Harvey and Lee. Of course, that makes sense. But the interesting thing is you see this connection right here, Sylvia Durin, right, if I pull that out, and a big collection of things around Durin. Now, if we dig into this document here, or dig into this here, can search in, and I can see I'm finding documents that let me understand that this is the interrogation of Sylvia Durin by the Mexican government. And we explore the documents, you see that she actually worked at the Cuban consulate in Mexico and was Lee Harvey Oswald's linked to the Russian KGB. All just became discoverable because this graph advanced out of this. It's pretty amazing what you're able to find with this Azure search with the help of those cognitive services. And if you want to try this at home, you can go out to this web app. It's available publicly at aka.ms/JFK files. And also, this is a public and available on GitHub, too.
Really cool stuff. Of course, you can reverse engineer some of this work on GitHub. So really cool, but you're also able to take document types that weren't searchable. This is paper. Like, this is handwritten paper.
Right.
Leverage Azure Search with cognitive services to really allow us to index all of these things, not only make them searchable, but also structured. How easy is it to harness these types of capabilities?
Well, let me show you how easy it is, Jeremy.
Okay.
So again, I've taken that document, all that scanned imagery, put it in Azure Blob Storage, and I've now hooked up my Azure Search here in the Azure portal to that storage. And all I have to do is literally set up search. I go down here, and I can just select the cognitive skills I want to add to my search, and I can just say, okay, it's literally that simple. But you remember we were using OCR in that search I did, so let me go ahead and choose OCR, and when I do that, you'll see additional skills are generated, so I can also pick additional attributes because of that turning on. So, and the JFK, of course, we use natural language and other things too. So all of them, literally, it's that simple.
So, okay, so we've seen a lot of different categories here in terms of the cognitive services that you mentioned earlier, but many of these are pre-built AI models that came about really as we started developing various services in Microsoft. So how did these come about?
Yeah, I mean, that's right. It's basically where our core engineering teams, along with Microsoft Research, have made several breakthroughs across the area of vision, language, speech, and search. And for example, we recently received the highest score for our machine learning capabilities through the Stanford question and answer data set called SQUAD. And it's a test of AI reading comprehension around 100,000 questions and their related answers. So pretty impressive what we're doing.
All right, so beyond integration with intelligent search, how can we use cognitive services, APIs, in our own applications?
Well, I mean, basically every application can benefit from cognitive services in some way, but let me give you a specific example. So we're here in Florida, and it's famous for many things, but it's including oranges, of course. So let's just take the example of an orange farmer. Currently, many orange growers are not differentiating their produce. They're just sending all of their oranges for juice production. But maybe they want to build a model that creates a sorting facility that uses AI that can decide what's grade A, and they sell those oranges at a more lucrative retail channel, or what's the lower grade B, and they send those oranges off for juice production. So what if they could use this AI to differentiate oranges by using computer vision, ensuring the oranges that are sorted to grade A go in one category and grade B in the other category, and using that intelligent edge to do that for them.
So it'd have to be a pretty smart system because bad and good oranges are pretty close looking, right?
You'd think, right? But let me show you how you can actually train a model to do that.
Let's try it.
So I'm out here in Azure within my computer vision area, and I have already preloaded a group of oranges into the site. And without any training, it's already identified that it's a group of oranges in a pile and has confidence of 85%. So that's literally just loading up the image. It's publicly available, and thanks to everyone participating, is getting to me that confidence.
And these look like beautiful oranges here as well.
They are lovely oranges,
yes.
Right? But the model hasn't yet been trained to decide what is a grade A orange or a grade B orange. But that, of course, makes sense because as the orange farmer, you'd want to decide your categorization of what's the threshold for grade A or grade B, right? So I want to do my own custom training on that. So let me do that now. I'll go over to my custom vision AI, and I've got a project I've started here on orange classifications. So go ahead and click in here. And I've got a number of images loaded to help start training my model. So you can see
Hold on, there's labels on some of these oranges.
and they're a little ugly, I know. I feel like it's sad for that orange, but you know,
Yeah.
it can't all be beautiful. On the inside, they're delicious.
They are.
So if I click on grade A, you'll see it's seeing that these are what I'm defined and categorized as grade A level oranges. And if I've started doing my training on grade B, so you can see some of those. But I want to go ahead and add another image to train that model further, so I can go ahead and just add images. And this is how I started the model and got it going. So I'm going to add a new grade B orange, open that up, and I'm going to go ahead and tag that as a grade B orange. Again, that's simple, and I'll upload that file. Uploading it, it's going to retrain, and then within a few seconds, I can go ahead and have that updated in my model's relearning. So let me do a quick test to see if how it's working. So I'll go up to my quick test area, and I just browse from my files. I'll start with a grade A orange.
Okay.
Drop that in. And I see it's giving me the probability that's a 99.5% causative that this is a grade A
It's the most
orange.
perfect looking orange I think I've ever seen.
Right? I mean, I guess it'd be hard to get that one wrong, right? But let me go try a grade B one here. Come here. Then let's grab a B and load that up and see how it does. So this case is 97.7% positive. You see it looks a little different. It was able to pick up on that level of detection. Now again, this is just a great example of how you can get started with AI for your own uses. I wasn't doing any coding. I just loaded up and trained the image. And you can try this today on Azure. It's on customvision.ai, where you can get access to this experience. And as we move forward, we're going to continue to make cognitive services APIs even easier to use. For a great example, just here at Ignite, we launched our unified speech service that now combines speech to text, text-to-speech translation, and the ability to train the model based on unique custom speech patterns, all as part of our custom speech API.
These are really great ways to leverage the AI effectively that Microsoft has built and tested. And our AI services are even getting smarter and smarter all the time as we look at more images. So what if you wanted to build out your own models and train those to work with your own data? How does that look?
Yeah. So for the folks who want the custom build their own machine learning models, kind of the more sophisticated needs, Azure provides a complete machine learning platform that you can take advantage of. And I'll just show you kind of one part of that here.
Okay.
I'm going to go into, again, back in my Azure portal, and I'm in my Azure Databricks notebook. And one of the great things about Azure Databricks is it enables both data scientists and data engineers to collaborate on shared projects within this interactive workspace. So you can easily pull in structured and unstructured data, you can prepare it, kind of called data wrangling, can clean it and get it ready and trained for my AI models right within the workspace. So what I'll show you here is actually an example of a shoe retailer, and they've built a shoe recommendation engine such that when a customer comes and searches, they're shown something that's highly relevant, so it's to hopefully drive up sales and results. But right now, the shoe retailer wants to then take that recommendation engine and use AI to make it even more highly predictive.
Do we do anything then to help with the types of algorithms and data models that you might use to make these types of recommendations?
Well, yeah, actually, one of the things we also announced this week at Ignite is a capability called automated machine learning. And that's basically using AI to train AI, in a sense, if you can think about it that way. But essentially, we test all of the different models using AI to see which algorithm performs the best, has the most accurate results, and then automatically recommends that to you. So it even expedites that process of it. You can also use simple SQL-like querying to easily explore the data within Spark here in Azure Databricks, and also get a sense of the current recommendations engine and its accuracy. So let's look at that. All right, so I'm down here. Now I'm going to first of all start, and this is their clickstream results. So let me show you what this means. Essentially, this is the frequency of clicks over the period of time. Now you see all the clicks are happening kind of at the end, which means that's when the shoe is going on sale. But
it's probably getting clearanced out of inventory, so it's probably when it's the cheapest price that we're going to sell it.
Right, which isn't great for my sales.
Right.
When I'd really want it to be lots of clicks in the beginning when the shoe is new and hot. So this gives me a clue that something's not right. So I'm going to go ahead and bring the data scientist into the notebook to see what so she can confirm what people are seeing in the different searches. So as I scroll down, I can see that this is the current results she's providing. Like, here's the target shoe, and then here's the related results, these woolly slippers for open-toed shoes.
Ugh. So I thought that we would,
Yeah, they do look like bugs, right?
Those aren't
Ugh.
good. What can we do to make the recommendation look more like that first shoe? That's
Yeah,
a
right.
better looking
It's
shoe.
not too surprising that they're recommending that. I'm not getting a lot of
I
clicks.
mean, they look comfortable, but I don't think you want to wear those in public.
Probably not. No one said that Uggs were good-looking shoes. All right.
Yes.
So what I'm going to do is I'm going to scroll down here. I'm going to optimize this model by bringing in a deep learning framework, in this case TensorFlow package, that can help provide recommendations. It's called Deep Image Featurizer, and it effectively breaks down the different attributes of the feature of every shoe in the catalog. So things like open-toed, heeled, color, size, type, more, so that I can really get a granular assessment of that. Now, once I feed those attributes back into my machine learning model, I'm going to perform the same search again and see what kind of results we get. If I scroll down here, you see there again is my target shoe. And now you see I'm getting very similar recommendations around that target. And even just to make sure it works on different types other than these open-toed.
And different colors of the same shoe. You can see even it's very close on the other open-toed models.
Yeah, see, you can see the accuracy of the results around. Again, I had now loaded up a different stiletto heel. I can see that I'm getting very similar results, so I feel much more confident about the recommendations I'm making. So then once I see that I've got a recommendation engine that's working well, I can then finally take that and distribute it in Azure Cosmos database, and I can integrate that into my machine learning model that's running the operational database of my web and mobile applications. So this recommendation is now going to be showing up across all of my customer experiences.
So really powerful stuff, 3 awesome ways to start to apply AI in your own day-to-day workflows and experiences, but where should people go to learn more?
Well, luckily, you can check everything that I showed to you out today. It's all public. So the JFK demo, the Azure Cognitive Services, the Vision API, and you can also sign up for a free 14-day trial of Azure Databricks. You can see that workbook and do that data wrangling and AI prep as well. And the power of all of this is that the more people who use the open frameworks who participate in this, the better the AI innovation gets. It really is kind of an open community approach, and we're all going to benefit from what we can harness.
Thank you, Julia. Coach, we'll keep tracking this on Microsoft Mechanics. If you haven't yet, hit subscribe now. Follow us on Twitter. Thanks for watching, and we'll see you all next time.